In high-scale enterprise environments, application downtime translates directly to lost revenue. And for the engineers tasked with fixing it, manual debugging at 3 in the morning guarantees severe fatigue. SentinelOps AI offers a different approach. It is an autonomous, self-healing pipeline designed to execute the entire incident response loop completely on its own. By automating log analysis, bug isolation, and code patching, this system cuts mean time to resolution from hours down to a matter of seconds. The objective here is to move beyond simply alerting humans faster. It is about removing the engineer from the high-stress firefighting loop entirely. To achieve this, the architecture is split into 3 distinct planes: telemetry ingestion, cognitive orchestration, and the execution plane. The cognitive orchestration acts as the system's command center. It is powered by highly efficient large language models, specifically leveraging Amazon Bedrock and Claude 3.5 Haiku to reason through error payloads. Giving an AI direct access to production infrastructure introduces significant security risks. To solve this, the pipeline uses the Model Context Protocol, or MCP, acting as a strictly scoped safety boundary between the model and the environment. Because the AI handles the active investigation and drafting of the fix, the human engineer's role shifts. They transition from a panicked debugger to a calm, passive code reviewer. The result is zero-trust automation. The AI is completely decoupled from production, and remarkably, this entire architecture operates within the AWS free tier. Imagine a production application throws a runtime exception, like an index error. AWS CloudWatch acts as the initial trigger. It uses metric filters to identify the text fingerprint of the crash in the logs and immediately rings an alarm. When that alarm changes, AWS EventFringe catches the alert and routes the telemetry directly to an AWS Lambda function. This ensures the exact context of the crash, timestamps, stack trace, raw error output, is preserved intact for the next layer. Because this entire ingestion plane operates asynchronously, it captures the critical telemetry instantly without adding latency or impacting the main application's performance. Once the data reaches the Lambda function, this ingestion bridge activates. It extracts the necessary incident metadata from the event bridge payload and wakes up the orchestrator. This diagram shows the cognitive core. The Amazon Bedrock agent activates and absorbs the full incident context. Unlike a standard chatbot, the agent executes a multi-step autonomous reasoning loop, evaluating the error and planning targeted remediation goals. But at this stage, the AI is essentially a brain in a jar. It can analyze the logs, but it is completely isolated, with no physical means to touch your files, servers, or systems. Cognitive intelligence is useless for infrastructure management without a secure mechanism to actually execute actions. That is where the execution plane comes in. The system utilizes the Model Context Protocol to bridge this gap. Think of MCP as a standardized, highly secure USB port that allows the AI to safely interact with external infrastructure tools. The agent sees the crash alert and invokes the MCP AWS SDK tool, fetching the precise historical logs surrounding the error's timestamp. Reviewing the logs, the agent identifies the index error and commands the MCP GitHub tool to download the exact source code responsible. With the code in memory, the AI applies its deductive reasoning. It analyzes the logic, realizes the array size is too small, and writes a logical if statement to patch the bug. Next, the agent instructs the MCP GitHub tool to apply this hotfix directly to the code repository, ensuring a permanent, unalterable audit stamp is appended to the modified file. Before finalizing anything, the agent commands the MCP code build tool to spin up a secure, containerized sandbox. It runs the unit tests against the new patch and verifies that the execution returns a clear past result. Through these MCP tools, the AI successfully isolates the root cause, writes a patch, and verifies the solution, without holding direct root access. Even with past tests, a strict operational constraint remains. No automated system should autonomously deploy code directly to a production environment. In the workflow's final step, the agent is routed to a governance bottleneck, opening a GitHub pull request. Concurrently, it logs an AWS Systems Manager approval gate, ensuring a manual human click is strictly required before deployment. Throughout this entire process, Amazon Bedrock guardrails operate in the background. They act as a strict semantic filter, blocking sensitive data leaks and mitigating prompt injection attacks from malicious inputs. This final gate ensures absolute compliance. The system operates as a tireless junior engineer, drafting the perfect fix, but always asking for final permission. Looking at the complete architecture flowchart, we see a seamless, automated pipeline that moves from a raw CloudWatch anomaly at the top down to a verified, tested pull request at the bottom. The natural question is the operational overhead. Running a continuous, highly intelligent analysis loop sounds expensive. However, the orchestrator is highly token efficient. By utilizing a compact model like Claude 3.5 Haiku, the inference cost drops to fractions of a cent per incident. Furthermore, the supporting infrastructure utilizes the AWS free tier, which provides 1 million free Lambda requests and 100 free code build minutes every month, easily covering standard operational volumes. This enterprise-grade, zero-trust automation is an actively deployable system that costs effectively nothing to operate. By executing these steps autonomously, SentinelOps AI drives a 95% reduction in mean time to resolution, aggressively minimizing the revenue loss to unexpected downtime. Just as importantly, it protects human capital. It eliminates severe engineer fatigue by intercepting and resolving issues before a pager ever rings. Because of the mandatory audit trails and manual approval gates, this workflow remains viable and secure even in highly regulated industries. The underlying logic here is straightforward. Modern systems to heal themselves, freeing your engineering teams to focus on architectural innovation rather than fighting nocturnal fires.